In this experiment, we'll use crystal violet, which is often used as an indicator in biochemistry. Crystal violet is, not surprisingly, a deep violet color, and it reacts with the hydroxide ion to form a colorless product. And we can then use a spectrometer to measure the concentration of crystal violet remaining as a function of time. From that, we can determine the rate constant of the reaction. You are going to measure the reaction rate at various temperatures. If we then plot the natural log of the rate constant versus the inverse of the temperature, we should get a straight line. The slope of that line is the activation energy divided by R, the gas constant. And that's coming about because of the Arrhenius equation, where we have the natural log of K1 over K2 is equal to 1 over T2 minus 1 over T1 times EA over R. So if we're plotting the inverse of the temperature along the horizontal axis, that's this term, and we have the natural log of the rate constant on the vertical axis, that's this term, we then have y equals x times m plus b, possibly. So m, our slope then, is the activation energy divided by r, where r is the gas constant, which has a value of 8.314 joules per mole Kelvin. So let's talk about safety. You're going to be using hot water that is almost, but not quite, boiling. It's plenty hot enough to scald you, so handle it with gloves and/or beaker tongs. Also, the sodium hydroxide and crystal violet are both corrosive to human tissue. Clean up any spills you have immediately, and if any touches your skin, wash the affected area immediately. In addition, the crystal violet will also stain both clothing and human tissue, so take care to avoid any spills.